Hi everyone, we're going to look at the 2.0 level learning targets from Unit 8, and we're going to walk through these. So starting with 8.2.1, we want to identify what each of these are in the picture. So if I look at HF, I have a line segment that goes through the center and touches both sides. That is my diameter. And I'm going to go down and then I'll come over here and do the other two. HA, well, HA is center to the outer edge, so that is my radius. DG, I'm looking over here, it is a line segment that ends on the edges of my circle. It does not go through my center, so that is a chord. And then point H here is where this line touches my circle. And so I need to figure out what this line is. So if I have a line that touches the outer edge of my circle at one place, that is my tangent line. And so the point where it touches it at point H is called my point of tangency. So then looking over here for my secant line is similar to a chord, but a chord has to be a line segment that ends. A secant line will go through my circle with arrows on both ends. So I'm going to say BD is my secant line, and I want to include the notation for a line with arrows on the top. Then my tangent line, we kind of already talked about because it goes with the point of tangency. It's this line here, so I'm going to say HJ, and I do want to include arrows on my notation because it is a line. It is not a line segment. So then we're going to move on to 8.2.2. I want to change this wording here. I printed them all and then, so I want to say a minor arc and major arc. So we're going to do two of each. So a minor arc is less than 180 degrees. It's less than half your circle. So I could say CD is a minor arc, and I want the correct notation, so I just do an arc above those two letters. I could have said DC instead of CD. I can say BC. I could do BE. I could do EB. I could even do EDC because that's still technically less than half the circle. So we have lots of options here. I'm going to stick with BC. For our major arcs, we want to make sure that we're covering more than half of our outer edge. It has to be more than 180 degrees. So for my major arc, I am going to start with E. I'm going to go around this way and pass through point B and end at C. So that is more than half my circle because half would be where my diameter would go. So EBC could be one of them. And with all major arcs, we want to include 3 letters. And then I am also going to do, I'm going to start at C, and I'm going to go through B, but this time I'm going to skip E and end at D, because I want to show that you don't have to use every letter. So C, B, D would also work. Again, I need the notation above it. We're going to go underneath, look at 8.2.3. So 8.2.3, we're looking for the area of the shaded sector. And it's really bad in the video, but my angle here, I'm just going to write it over here, is 60 degrees. So that central angle there, and then my radius is 8. So to find the area of a sector, I am going to do pi r squared, which will give me the entire area of a circle, but I want to multiply that by a fraction of my central angle over 360. So that portion of the circle, I'm just taking that sector piece. That's why I need the fraction there. So I'm going to plug in what I know. Pi is a number. My radius is 8, so I'm going to put that inside parentheses with my exponent on the outside. And then for my fraction, my central angle is 60, so I'm going to do 60 over 360. Then with this, I can type this all into my calculator. I just had to get my calculator out. So we have pi 8 squared times 60 divided by 360. And I want to make sure that my fraction is inside parentheses. And so for my area, I get about 33.5, and those will be units squared. I just don't have units on the 8, so we're just going to say units squared. For 8.2.4, we're looking at the arc length, so the length of our arc. For this one, we're going to take the formula for our circumference, which is 2 pi r. So that will give us the entire outer edge of my circle. But again, I only want a portion of it, so I'm multiplying this by theta over 360. Because 360 is my entire circle, I only want the central angle of what I'm given here. So I'm going to plug in what I know. My radius is 2, and then my central angle is 150, so I'm going to do 150 over 360. And I'm going to type this all into my calculator. So I'm going to start with 2 pi times my radius, which was 2, times my fraction, 150 divided by 360. So the length of my arc is about 5.24 if we end up rounding it. And then we were given units for this one, so we're going to say yards. Our units are not squared because we're not finding the area of anything. It's just the length of that curved piece on the edge. The last 2.0 for this unit is determining the center of a circle and the radius of a circle when given the equation. So for a circle, the template looks like this, where we have x minus h quantity squared plus y minus k quantity squared equals r squared. So for our center, we're looking at the number that's inside of the parentheses with our x. It looks like a positive 2, but we know it's actually the opposite of what it looks like. So the x value of my center would be negative 2. Because that number's with my x, that's the x value of my center. So then the y value of my center, I look at the number that's with my y, and it looks like a positive 9, but I do know it's the opposite of that, so it'll be a negative 9. So my center is negative 2, negative 9, and my radius is going to be the square root of this last number on the end. So the square root of 9, which ends up being a nice whole number of 3. So I have a radius of 3. I hope that helps reviewing the 2.0 learning targets.